Live streaming is on.
Is this frequency in use? Is this frequency in use? Is this frequency in use? Greetings. This is W2NDG on the OMARC 805 repeater, starting the 8 o'clock Sunday night Science and Technology Net. First, let's pause for any emergency traffic. Any emergency traffic, please come now. Okay, nothing heard, which is always good. Once again, this is Neil, W2NDG, calling on the OMARC Sunday night Science and Technology Net. This is a weekly net where we discuss broad topics of all science and technology, sponsored by the Overlook Mountain Amateur Radio Club. This net is hosted by yours truly, Neil, W2NDG, and co-hosted by Jim, KD2. I'm sorry. Oh, wow. Jim, I apologize. It's been a crazy day. K2BHM. Well, here we are broadcasting live from my office. There is a live stream accompanying this. And that stream, I've put up links on the OMARC Facebook account and my own Facebook account, and also on the 835 on the 805 webpage in the forum. If you don't have access to any of those or can't find that, if you simply Google W2NDG Science and Technology, you'll find my YouTube channel, and the live stream is there. We're trying something a little different tonight. We're going to have some graphics as part of a presentation, and we're going to see how that works. So I will try to keep tonight's discussion literal enough and explained enough that hopefully we don't have to have the graphics for you to understand what is going on, but the graphics will be nice, they'll help, and I will post them, or at least a link to them, on the 835, on the 805 afterwards. All right. This is a directed net. The first part is going to be a lot of talking and listening, but we will take check-ins now, and then we'll take check-ins again after the presentation portion of the net. We will take Jim first, KD2BHM, or K2BHM. Sorry, Jim, again. And Jim, if you're there, please come now.
I'm here, K2BHM. It's a little confusing. I did get your YouTube live video up, but just like when you call into a radio station, there's a delay, so keep your radio turned down.
Yes, and it's a double stream tonight, which means I'm going to be using something else to capture the video and send it off to YouTube. So there's a slightly longer delay than normal, so we can have the presentation slides up on the screen. I am monitoring the stream so I can see what the delay is, and I will talk about the slides as they come up instead of as they come up on my screen. So we'll work all that out. But first, let's see who's around today. And to check in, you do not have to be a member of the OMARC Club. You just can be on the repeater. That's fine. And you're going to check in by giving us your call sign, your name, and your location. Please come now.
This is November 2, Foxtrot, Zulu Charlie, Tom in Fishkill. Kenny, K2KRP in Marbletown. KD2 VAH, Jim in Poughkeepsie. This is W2 RKN, Jerry, my part. KD2 GGS, that's in Kerhonkson.
I think that last check-in may have been Dave, K2JLV. Was that you? I'm just not sure. Did anybody else get a better listen on that than I did? All right, Dave, we got you that time. Thanks. All right. So far I've got N2 FZC, Tom and Fishkill, K2 KRP, Kenny in Marbletown, KD2 VAH, Jim in Poughkeepsie, WA2 RKN, Jerry in Hyde Park, KD2 GGF, Matt in Kerhonkson, and K2 JLV, Dave, and I assume you're home. And is there anybody else who'd like to check in for the Sunday Night Science and Technology Net? All right. Well, that's fine. I'm going to get things going here as far as getting the presentation set up. And I need to go back to full screen mode, and that should do it. All right. So first of all, I have to mention that Raspberry Pi has been something that has affected so many of the maker-oriented communities since it came out. And it's something that we hear mentioned on the repeater quite often. It is a computer, but we're going to talk about, what kind of computer, what it is, where it came from, and what it can be used for. And there's so many ham radio purposes and non-ham radio purposes. Jim, do you have like a 10 or 15 second or 30 second just preview of the different things you use yours for and how it's changed the way you engineer things?
Well, get to be a Jim. The list is long. I've got I gotta have over a dozen pies going here. Different webcams, monitoring different things. I built up a specific Pi Zero the temperature sensor so I can remotely monitor the freezer because my freezer died at the beginning of the pandemic and I lost everything. So the replacement is now monitored. I've got a server here. I've got a network multimedia server that I store my pictures on, and you can play it into Roku and look at your pictures on the TV as a slideshow as well as backing them up. There's the Pi hole that helps get rid of ads on your internet service. There's just so many different things. Software-defined radio interface, Pi-Star for digital DMR. They're all over the place.
All right, excellent, and thank you. And we're going to get into some of the more ham-oriented uses. Some of the slides here, this presentation was created for the Ham Radio University group. So some of these introduce me a little bit more. And there was also a bit of a survey, which we're not going to get into tonight. We'll discuss this afterwards. So let's get into the Pi itself and what it is. So what is a Raspberry Pi? And this is what we're going to cover: what it isn't, what SoC means, or system on a chip, RISC versus CISC, or RISC versus CISC, a little bit of history and models, layout and features, what can you do with it, and ham radio applications. So we'll start at the beginning here. A Raspberry Pi is simply a computer, a small, inexpensive computer. Quick draw. It has the same components of a larger computer system or equivalents. It has input, output, memory, storage, audio, video, more. A Raspberry Pi is not the same thing as a microcontroller board like an Arduino. Microcontroller specific systems like that. It does have some similar features like a GPIO bus, which is an interface for communicating with the outside world. And it can do many Arduino-like functions, but it is a full-fledged computer. So in some ways, it's the best of both worlds of having both a microcontroller and a fully addressable computer at the same time. Now, you can get into the nitty-gritty of this and tell me that, well, there's versions of the Arduino that have full interfaces and act this way. And there's also now a new version of the Pi that is more like a microcontroller board, but we're talking about the mainstream editions and uses. So I used the term SoC, or system on a chip. What is that? We have so many devices that we use that are system on a chip. Your phones, a lot of the embedded devices in your homes. And what it is that as time has gone on and we've made the microscopic transistors and chips even smaller and smaller, we've been able to cram more uses, more devices, more things into these chips. So where in a full-fledged computer, you have a processor, you have a memory controller, you have a video controller, you have input-output controllers and everything. The ARM system on a chip processors in something like a Raspberry Pi have everything in one chip, or most everything. And it does make things a lot simpler, and it makes things a lot less expensive. So that's the type of chip that's in this. When we refer to the term ARM, ARM is a RISC chip. RISC means reduced instruction set computing. There have been a number of RISC-based processors, or the processor being the brain of a computer, over the years. Apple dove into that market very early on and made their Macs and, of course, still their mobile devices using chips that ran a RISC or reduced instruction set. It makes for a much lighter weight device. I don't mean physical weight, but as far as what it has to carry around to be compatible with things. Complex instruction set, or CISC, is your Intel processors. And there's a lot of backwards compatibility dragged around with them and a much more complex set of code to make them function. So years ago, when Apple used to compete head-to-head against Intel, one of the jokes in the industry was you're not comparing apples to apples when you look at the numbers when you try. And of course, you're comparing apples to PCs, but Apple running one of these RISC chips at a certain speed was a much better performing computer than an Intel processor at that same megahertz or eventually gigahertz speed. So they're more efficient, but they do have some drawbacks, and a lot of that has to do with the hyper complexity of some of the operating systems that we run on them. We don't need that. Linux is capable of running on all of these systems, and that's what we're going to be looking at. So the ARM Cortex A53, which was in the Pi 3, is not going to compare to one of these Intel processors as far as its efficiency. So where'd the Raspberry Pi come from? W2NDG on the OMARC Science and Technology Net. February 2012, the Pi was released to the public. There were a lot of previews and talking about it, but its main goals were education and accessibility for people who may not be able to afford a full-fledged computer, and to be able to teach kids code and how to program. Now, this is not a new concept. A long time ago, back in Commodore VIC-20 and Commodore 64 days, there was a computer in England called the BBC Micro from Acorn Computing. The British government subsidized the whole project to get computers into the hands of kids, to teach them about computing. Let me draw. That was the original goal. They wanted the computer that would sell for around $30, that would work with common computer hardware that was easy to come by as far as displays and keyboards and such. And they built it around an operating system and a set of applications so that kids could learn how to program. And that was the original idea of this. And one of the neat things, which is hard to find these days, is that one of the operating systems that you used to be able to grab from the Raspberry Pi site to run on a Pi is something called RISC OS. And RISC OS was one of the first point-and-click graphical operating systems that was mainstream, and it was designed to run on those old Acorn computers. So because they all ran ARM processors even back then, they ported that operating system to the Pi. It's not extremely useful, but it's a nice piece of history that you can look at. Now let me drop. The original Pi was insanely popular. It was hard to get. Personally, I jumped on it early, and I was able to grab one. The original models were short on RAM, though. So they had to do a quick modification to the features. There, I have on the screen now is the Model A. Now, they refer to, there's two main models of Raspberry Pi up until recently, the Model A and the Model B. They still make a Model A, and I don't really cover it a lot in the slides, but the Model A was a more stripped down version of the Pi, and the Model B was the full-featured version. The A only had a single full-size USB port, and it was missing some of the other features. Some people ask me sometimes, why would I even want a Model A? Let me drop. Mostly it has to do with power. If you're designing something that needs to run off of batteries for a very long period of time or off of solar power, the A does use quite a lot less and can run for much longer time in a situation where you're just running an embedded device and don't need a lot of the extra peripherals. But the original model, 700 megahertz, single core processor with 256 megs of RAM and one USB port, no Ethernet, but HDMI. They had composite video out, both the A and the B, and analog audio. You could also grab audio off of the HDMI, digital audio, but they had that analog audio output. The original B model, let me drop. Same 700 megahertz single core processor, but 512 megs of RAM. But the first ones had 256, the very, very early ones. I have one. I used to use it as a print server. Worked rather well for that. But the B gave you 2 USB ports, a live Ethernet port, physical networking port, and then that same HDMI composite analog audio. Both of these ran on full-size SD cards. And you put the operating system on the SD card and booted into it that way. So those are the original two. Let me try. The B Plus came out next. There was really no change in the processor performance. One of the things you'll note, for those of you who are actually watching and those who want to look at it later, is as we go along, even sometimes when the speed didn't change drastically, the component count would go down sometimes. The B Plus introduced a form factor that stayed with the Pi through several generations after this, which was 4 USB ports, physical Ethernet port, and now different HDMI, still with the analog audio though, but a micro SD card, so shrinking that down, and still the 700 megahertz single core processor though, but a much better layout. And now, with the extra USB ports, it was much easier to attach peripherals and still able to have Wi-Fi. So the Raspberry Pi 2 came next. Now we're starting to increase performance. 900 megahertz quad-core processor, 1 gigabyte of RAM, still with Ethernet, HDMI, composite analog audio out, still there, and the micro SD card. And they added some extra GPIO pins to this one. Also, I should mention with the Plus model leading on, they improved the power regulation. There were some issues with the early ones and the power regulator not holding up long term. So this is the Pi 2 Model B, still following that same form factor. The Raspberry Pi 3 Model B went up to a 1.2 gigahertz quad core and a 64-bit processor this time. Important to point out, though, that the operating systems that we run on the Pi are still 32-bit, but they are working on a 64-bit version of the Raspberry Pi OS. Still, everything else form factor-wise was the same, but now Wi-Fi and Bluetooth. So, big plus because we were all adding our own Wi-Fi onto them. Now the Pi was capable of connecting to Wi-Fi and Bluetooth devices right out of the box. So definitely starting to get a little more useful. And now we work up to the Raspberry Pi 3B Plus, so a Plus model on the 3. And for those of you watching, you can see that component count is really dropping. The board's starting to look a little more empty. Now we're up to 1.4 gigahertz quad core, 1 gig of RAM. Everything else is still the same, but faster Wi-Fi, better Bluetooth, and now optional power over Ethernet, which there's plenty of installations out there where being able to get power from an Ethernet jack is advantageous. It's a good feature to have. And now things start to change a little bit. The Model 4 changed the form factor for the first time in a while. Now we're up to 1.5 gigahertz quad core, 64-bit ARM version 8. And for the first time, choice of RAM, 2, 4, or 8 gigabytes of RAM. USB 3, which is much faster than USB 2. So you get 2 USB 2 ports, 2 USB 3 ports. Gigabit speed Ethernet. And it's important to note that one of the reasons why they were able to do this was because of the USB 3 option. The Pi Ethernet jack was always kind of like a cheat. It wasn't a separate Ethernet subsystem on the Pi board, but part of the USB subsystem. So there was just a tiny embedded USB to Ethernet adapter on the Pi. Now that we have a USB 3 bus, now we can speed the Ethernet up to gigabit. Let me drop for a sec. This is W2NDG on the Sunday night Science and Technology Night. And we've changed other ports around. So there's still an analog audio out, but we lose the composite video portion of that. There are now 2 HDMI ports, but they are micro HDMI. But you can run dual displays. Power has changed from USB power, old style micro USB power, to USB-C power. So we're using a USB-C port to power. But once again, they upgraded the power handling and voltage regulation. We have dual band Wi-Fi, updated Bluetooth again, and possibly, I think maybe the composite video is still there. I'm not positive. That's something I haven't tested myself because so few of us use that type of video anymore. But still with a micro SD card, power over Ethernet available, and the GPIO bus hasn't changed, but the form factor changed to where if you like to put your Pi into a case, the same case isn't going to work anymore. So for those of you who haven't seen one in person, you know, a Raspberry Pi is about the size of a credit card, the board anyway. There are definitely situations where you would want something smaller. And a few generations back, the Raspberry Pi Zero came out. The Raspberry Pi Zero is the size of a stick of gum. Wrigley's, not Trident. So regular stick of gum with a couple of ports on it and a few chips. The first version of the Zero was a 1 gigahertz single core processor, 512 megs of RAM, 1 micro USB port, and 1 for power. Even though it does have 2 micro USBs, 1 is power only. The existing USB port can be used for peripherals, but you need one of those little OTG adapters to expand it out to a full size. Analog audio only through the GPIO bus, and it had still has HDMI, but mini HDMI, which is a strange in between the micro and full size HDMI, but you can get the adapters. It's got the full GPIO bus, camera port, SD card, and they sold them for $5. How can you go wrong with that? And people started using them for all sorts of embedded projects. Jim will hit on some of the things he's used them for and where they come in handy. But they upgraded again. The Raspberry Pi Zero W, now with Wi-Fi, so, which was a big plus for something that didn't have an Ethernet port and only 1 USB jack. So now that you have Wi-Fi, you can get a lot of the configurations in. Bluetooth peripherals, definitely eliminating the need for all these crazy interfaces and USB splitters and everything else. They still have kept these as a single core device with a simpler processor only because of power requirements and heat. You don't want to get crazy with these. Still $5. So really neat stuff. Now, more recently, it went in a completely different direction. Let me drop. The Raspberry Pi 400 was released not that long ago. It's closest in architecture to the 4, but now they've taken the board and made it more linear. If you're looking at the pictures, it shows the board that's inside of a Pi 4 versus a regular Raspberry Pi. And basically, if you were to cut a regular Raspberry Pi 4 lengthwise and kind of fold it out on itself, that's what they did with the form factors. They made it one long, narrow board. And they flipped all the peripheral ports around so everything is linear in one straight line. They took this and they put it inside of a nice white keyboard case. And everything is accessible along the back. Specs were jumbled a little bit for this one. Only 4 gigs of RAM compared to the 8 Max on the Raspberry Pi 4. 2 each of the USB 2 and USB 3. It does run USB-C power. Like the other one, it still has the micro HDMI ports, 2 of them. It's a neat little package. I have one here, and you're getting to a point with the Pi 400 and the upper levels of the 4 where you can plug one of these into a monitor, a keyboard, a mouse, hook it up to your network, and use it as a desktop computer. Now, it's not as fast as your $2,000 gaming computer, but it's usable, and it works quite well. Let me drop. They really improved the cooling with the 4 also. And one of the the 400. One of the problems with the Raspberry Pi 4 is that if you're going to use the 4 for anything taxing, and there are several ham radio applications that are, they really get hot, and you really need to put them in a small case with some kind of active cooling. A heat sink on the processor and a little fan, and you're usually going to be okay. But they really do need a little extra cooling. There's some slides that I'm going to skip over here that just talk about the layout of the parts on the board. And we're going to go on to operating systems. Let me try. If you look on the Pi site currently, they've whittled down the available operating systems a little bit. They used to have a lot more available. Like I was talking about RISC OS being there. It's not anymore, but you can still track that down. But there's 3 main operating systems that they offer through the regular website. One is Raspberry Pi OS, which used to be called Raspbian. It's a version of Linux built off of the Debian operating system. It's regularly updated. It's mature at this point. It's come a long way. It has a lot of development, open source development applications in it. Those of you who kind of shake your head and say, I could never write code, I could never write a program, this is where you start. There are there are applications in here and learning packages that can get anybody up and writing simple computer code. A lot of it's aimed at kids, but it's great software. I've tried it myself. There's nothing wrong with using it if you're not a kid. So let me drop. The 2 others on here I'll touch quickly. LibreElec, which is a set-top box Linux distribution. Basically, you put LibreElec on a Raspberry Pi, hook it up to your TV, and it's a Kodi entertainment system, kind of like a Roku or one of those other set-top boxes. Ubuntu Desktop is a Raspberry Pi version of Ubuntu. Ubuntu also comes out of the same root version of Linux as Raspberry Pi OS, Debian. But Ubuntu is probably one of the most popular versions of Linux that you'll find out in the commercial computer world. All of these are free, open source. Ubuntu isn't as mature as Raspberry Pi, but if you're a Linux person and you used Ubuntu, it'll seem a little more familiar to you. But they're still ironing out some of the little bugs with it. So there's certainly other operating systems you can get on it. Most recently, they figured out how to get a version of Android onto the Raspberry Pi that actually functions. And there are a lot of reasons why it didn't work well before. So I'm going to drop, take a break for some additional check-ins, and have Jim talk a little bit. This is Neil, W2NDG, on the Sunday Night Science and Technology. All right, any additional check-ins? Please come now with your call sign, your name, and your location. All right, nobody else right now. Jim, any comments, additions, add-ons? facts up to this point.
Thanks, Neil. Jim here. Well, I'm going from memory, but I'd like to back up a little bit and go back to Arduino. And we touched on it briefly, saying that there was differences between the Arduino and the Raspberry Pi. And basically, from what I remember, the Arduino, you're not going to go and connect up a keyboard and mouse and monitor and plug it into the internet, Wi-Fi, and stuff like that. It's basically just a bare bones machine meant for doing control work and stuff like that. Interfacing, whatever, controlling things. One of the things that came to mind is I was looking at the LEDs that have the chips built into them that takes 21-bit serial code and determines from that the light intensity of the red and the green and the blue in that particular device. And once it grabs what it needs, it passes everything else to the next one down the ramp. So you can send out like 2,100 data bits and control 100 different LEDs in one big long daisy chain string. And for that, you need the Arduino because it does one thing, it does it very well, and then it goes on and does the next thing. It's a linear single user type operation. Let me drop for a second. The Raspberry Pi, on the other hand, is a multi-user, multi-application type device. You can have 3, 4, 5 different people locked into the same Raspberry Pi at the same time while doing different things. And if you're trying to set up a data stream to control your LEDs and somebody else logs in, there goes your timing. And everything goes out the window. And then, like we said, Raspberry Pi, you got the keyboard, the mouse, the Wi-Fi, the Bluetooth, 1 or 2 monitors, all kinds of stuff. So that would be the primary difference between the Arduino and the Raspberry Pi. And let me jump over to another topic. Drop in a second. We talked briefly about reduced instruction set or complete instruction set. What's the difference and what difference does it make? Initially, microprocessors, you had an 8-bit system and that gave you the possibility of 256 different commands. And then they expanded on that, going with 16-bit, 32-bit, and so that means now you're going to have 65,000 commands and whatever. Well, what's a command? Move a number from this port over to this storage location. Take this storage location and add it to that storage location. Take that location and subtract 10 from it, whatever. Little individual commands in your program perform different functions and take the input and generate an output. Now, when you start talking about gaming and high-end computers and stuff like that, there are all kinds of commands to transfer pages of code from memory over to video and so forth and so on, complex graphics and doing sines and cosines and tangents and all kinds of weird way out stuff. And there's thousands, maybe 50,000 commands in a CISC. And for the most part, we don't need that. We use maybe like 50 or 100 different commands. So if you've got a computer system that only addresses 256 commands, and it's the ones that you use all the time, you can cut down your access time and your processing time and so forth and so on and make it much more streamlined and much more faster and efficient than somebody that's going to do one of 50,000 things, and which one do you want next? So anyhow, that's a good point to stop at, and toss it back to you, Neil, and see where you want to go from here. J2BHM.
All right, thanks, Jim. This is Neil, W2NDG, on the OMARC Sunday Night Science and Technology Net. So, as I said, early on, and I was saying on another net earlier today, this is a bit of an experiment to try to do a presentation style thing during the net. It's definitely a lot of information, and I think there's, we're going to have actual video presentations as part of soft meetings going forward, and then eventually, hopefully, hybrid meetings once we're in person again, and we can do a lot more things like this. But I wanted to see how this would work. There's definitely more things to talk about, and what I can do is skip right ahead to some of the ham radio applications here. I can go really quick and just explain that, we talk about the Raspberry Pi as a computer, and you can use it as a desktop computer, but it does have some small limitations. One that not all software is available for it. Even software that's available in other versions of Linux may not necessarily run on it. However, most of the useful packages have been ported. Another thing, which slides up for now, frequently I get asked if somebody has, tried, and I used a generic name here, the Cranberry Deluxe Mini, which doesn't really exist, or any other generic name. There are lots of Pi lookalike and workalikes. So many companies have come out with things like them. Very few of them have really caught up to the Pi in that they don't have the support. They don't have the community behind them. There are a couple you'll hear more about. The Beagle boards, which a great online SDR project runs on, and something called the Latte Panda, which is a Raspberry Pi sized board that can run full-fledged Windows 10. There's so many things you can do with the Pi, and of course we want to know what it does for us as hams. But not everybody on this is always a ham radio operator. We do have some people in the video chat sometimes that show up, but obviously a computer, a media center, a music player, weather station. You can make your own weather station like the ones we've been using in the club out of a Pi and some sensors. Robotics, web-enabled controller, education, remote camera, terminal or thin client, gaming. There's all sorts of projects for making handheld and console gaming systems out of these things. Retail kiosks and other public information kiosks, and small servers. At the bottom of my list here that I made when I put this together, it says ham radio. I mean, that's what we're here for. What can we do with it for ham radio uses? As the Pi has evolved, there's more and more that you can do with it. And a lot of the Pi Linux applications have been ported over to it, and a lot more have popped up because of the Pi being so portable and so versatile. Some of these projects that I get into where you build a radio, it's not that hard to design something that would have a Raspberry Pi small screen display on the front and just build one right into the project. So one of the common things that people ask about with these is software-defined radio, which is a topic for another night, definitely. But one of the really cool things about the newer versions of the Pi is that they are now fast enough to actually act as a software-defined radio, not just as an SDR server or access point, but a full-fledged SDR running on one of these. It's pretty neat. So it does lots of other uses. W2NDG on the OMARC Sunday Night Science and Technology Net. Something called ADS-B airplane tracking, which is definitely a whole topic for another night. Digital radio hotspot, all those hotspots that some of us have, a lot of us talk about, are all running, not all of them, but the do-it-yourself ones are all on Raspberry Pi boards. You can make an Echolink node out of a Pi, APRS box, Whisper, antenna and rotator controls, TNC, a spectrum monitor is a great project for that, but now we have the Tiny SA. a PSK31 terminal or other digital mode terminals. I have a little self-contained Pi I can use for that. Rig control. There's also a commercial project now called Rig Pi that you can buy from MFJ that uses a Raspberry Pi as its base for remote controlling your rigs. And a transmitter. That one's a little weird. How do you use a Pi as a transmitter? Not with a transmitter, as a transmitter. So a long time ago, some very intelligent hams discovered that you could modulate a couple of the GPIO pins in the Pi fast enough to actually produce an RF signal. Let me drop it. So you've got radio waves coming right out of the Pi. I mean, plenty of these computer devices put out interference, RFI coming out of all sorts of embedded devices in your home. But what if we could harness that? What if we could actually use that? Something interesting to think about, and they did. And they went in a number of different directions. One of them was something called Pi FM. The Pi FM project is a very, very lightweight Raspberry Pi distribution on a micro SD card. You load it onto the Pi, and you put a bunch of music files, MP3 files, in the root directory, and you configure it a little bit, tell it what frequency to broadcast on, and how to play the files, whether random or in some order. And it transmits the music in stereo on an FM frequency of your choice. I think the project is still out there. Don't know if it works on the Pi 4, but it definitely worked on the older ones. And what a neat idea. You have to be careful with it. Don't hook it up to a big antenna, because they tell you just put a really short little wire on it and use it around your house. Anything broadcasting off of your property is not legal. So they started modifying this and getting it to produce VHFM on 2-meter frequencies, 440 frequencies. They were able to get it to modulate up there, using it as a very low power Fox Hunt transmitter, and even for it to be able to put out digital modes, SSB, CW, in the HF bands. There's a group called Tapper, the Tucson Amateur Packet Radio Group. They make a little board or hat that goes on top of your Pi that filters and buffers and very, very slightly amplifies the signal coming out of those pins. And using some software allows you to turn your Raspberry Pi into a Whisper transmitter. Whisper is not a QSO mode, it's a unidirectional mode for propagation reporting. It transmits a long, drawn-out signal over 2 minutes with your location, your call sign, your power level, and all that gets fed into a server system by the people receiving it and put onto a map so you can see propagation conditions. Whisper, WSPR. Neat stuff. QRP Guys was also making a kit version of this with through-hole parts. But now I think it's board only. They're no longer selling it as a full kit. There have been all sorts of other modifications made for adding Raspberry Pis, particularly onto the micro BitX transceiver. There are 2 interesting online projects, the WebSDR project at websdr.org, and OpenWebRx at kiwisdr.org, kiwisdr.com, that are capable of working with the Raspberry Pi. The Kiwi one is designed more for the BeagleBone devices, but it will work with a Pi, with an RTL SDR dongle. You can really get into some crazy stuff. You can get into Packet using TNC Pi, and there's APRS software and hardware for the Pi. I mentioned the hotspots already. And there is a slimmed down version for the smaller screens of FLDigi and the WSJTX and other digital mode software for doing digital modes on HF and VHF. So you can create one of these little self-contained digital mode boxes like I did. Let me drop. There is a book I'll recommend called Ham Shack Raspberry Pi. Somebody published a whole book on doing this stuff. Jeremy Stevens, Ham Shack Raspberry Pi. And if you just Google Raspberry Pi ham radio, you'll find a lot of other information. And I think another book now as well. There is a specific ham radio version of the Raspberry Pi OS. So it's basically the Raspberry Pi OS or Raspbian with all of the ham radio applications you could dream of using already loaded into it. It's called Ham Pi, Ham-Pi, Ham Pi. It has its own groups.io group, and it's a full-fledged ham radio distribution for the Pi. Let me drop. I'm going to end the presentation part of this and just go back to the regular streaming video. And yes, you don't want to have the volume up on your streaming because it's going to get rather confusing. There we go. And I'm back on video. So let me drop. This is W2NDG on a Sunday night, OMARC Science and Technology Net. Thank you for putting up with us here for a little presentation experiment on the net to see what it's possible to do and possibly also what people are willing to put up with. I know running a presentation in an audio format is not necessarily ideal, but I try to at least make sure we're giving enough information that you can follow along without having to look at the slides. So that's one of the important things here. So let's pause. We'll take some more check-ins really quick, and then I'm just going to throw it out for any questions about this and any related topics. This is W2NDG. Any additional check-ins out there, please come now with your call sign, your name, and your location. All right, this is W2NDG, Neil, on the OMARC Science and Technology Net. First, Jim, any more comments on the little bit at the end there?
Hey, K2BHM here. Just wanted to point out there's a lot of information out there in setting up the Pi and stuff like that, and so forth and so on. And I wanted to mention that I did put together some little articles. They're on the 835 on the 805.net. So if you go there and check into the archives, Raspberry Pi archive, you'll see several small articles on an introduction to Pi, the difference between Windows and Linux, explanations of permissions, how to set up a Pi and get it up and running, and then some other things, fixed IP addresses, moving OS to a hard drive, how to access from the web, and a few other things like webcams, temperature monitor, whatever. So if you want to start off easy, go there and do some reading, and start with something simple. Don't take any real involved project and jump in with both feet. Start off small and get your feet wet, get used to it, get to feel of things, and it'll be a very happy, rewarding experience. Back to you, Neil, K2BHM.
All right. I turned my power down a little bit because I heard the fan screaming on the radio. I'm definitely giving it a workout tonight. So hopefully I'm still getting it okay.
Still good till quieting.
All right. Well, thank you, Jim. And I will mention, poking around on the raspberrypi.org site real quick, there are some other options for download of Raspberry Pi operating systems than what I mentioned, but most of them are other Ubuntu options, and something called RetroPie, which is the OS for turning your Pi into a retro gaming system, which is kind of a cool project if you're into that stuff. All right. So we talked about using it for ham radio and everything else. And there's still, like I said, the basic model, I believe the 2 gigabyte Model 4 is still $35, with the 4 and the 8 costing a bit more. But definitely still an affordable device to get into for everyday stuff. We hope to do something like this as a full hands-on, because I definitely have some neat stuff already set up, and I know Jim does as well. So let's drop the part here where we're just supplying mountains of information and see if there's anyone out there that has any questions or comments so far, or wants to add anything to all this that we've talked about. So we won't do a round in the circle tonight. Just so if anybody wants to throw a comment in or a question or anything, just call sign and name real quick. Come now.
This is N2FZC.
All right, Tom. Go ahead with your question or comment.
Somebody else is in there. I'll pause momentarily. Yeah, this is a W2NDG. Log me out, please.
Oh, sure, Jerry. That's fine.
Sorry, N2FZC. Question and a comment. Now, the presentation that you did, is that going to be available somewhere for download or something?
I'll put a link to where I have it posted online. You can grab it from a shared folder in my Google Drive, or just watch it right in Google. And I'll put it on the OMARC Facebook page, and also up on the 835 on the 805.net website.
All right, very good. Yeah, okay. So the link's there. Good deal. Let's see. There was something I picked up at a Maker Faire a while ago. The PC Arduino. You just plug a keyboard and a monitor into it, and program the Arduino without having to. That was a pretty neat device. Played it with a little bit, and also played with the Raspberry Pi when it first came out. But I haven't touched it in years, and didn't realize how far they had come with it. So I'll have to get back into it. That's my comments for now. Interesting stuff. And to FCC back to that.
All right, and thank you. Yeah, it's definitely evolved in leaps and bounds. The device has come so far. It used to be that you really had to be into the technology of it and the embedded uses and the things you could do with it when it first came out, because to an average computing person, it wasn't necessarily as versatile as we wanted it to be. It didn't make a particularly useful desktop computer once you had all the software installed. It was a little sluggish, but for purpose-built things, all the different things that we used them for early on, they were amazing. And there were certainly ways you could use it as a regular computer if you knew where to find the stripped-down browsers and other applications that would run better on them. So, all right. Does anybody else have any questions or comments tonight?
Control. K2JLB, Dave with a question, actually.
All right, Dave, go ahead.
First of all, thank you very much for the presentation. Huge deep dive. Very cool. And things I did not know about Raspberry Pis in there. But my first and I guess most pertinent question is about the PoE system on it. What type of PoE does it take? Is there internal voltage regulation? And does it require that you break out the power out of the Ethernet port and plug it into the USB port? Okay, back to you then.
All right, and it's a great question, and I haven't used it personally, so I'm going to be going based on what I can find by looking up. The PoE compatibility on the Pi is an add-on compatibility. There's a hat that you add on, so it rides on top of it, and it does include a cooling fan. It'll work with the 4 or the 3B plus. And as far as I know, it simply adds the capability directly through the existing Ethernet port. So you're not adding another port to it. And it does add on some beefed up power regulation as part of its function. One interesting thing about the Pi's GPIO bus is that a lot of the physical ports are duplicated or can be duplicated through some of the pins in the GPIO. So it's probably using the functionality of the GPIO to get this working. Let's see. Yeah, it says it's a fully isolated switched mode power supply, being able to handle 37 to 57 volts DC with a 5 volt, 2.5 amp output for the Pi. And comes with a cooling fan because I'm sure it needs one.
So I just want to understand correctly, because I don't know a lot about PoE other than what I used to do with using the breakout jacks that you used to get on the end. You plug into, like say, a WRT54G router or something like that. So PoE has specific pins in a Ethernet RJ45 that are standardized. And then it sounds like what they're doing is they're taking a connection there, running it through a power regulation hat, and then dumping it in through the GPIO to run the Pi. Does that sound about right?
Correct. It looks like it's exactly what they're doing. And the hat runs about $25.
Okay, very cool. I did not know that existed. I was wondering if it was actually built right onto the board. I know there's no serious power regulation on the board that I know of, except for plugging down 3.3 volts for the GPIO. Okay, thank you very much. That's my question. KTJLD, back to you.
All right, Dave, thanks for the question. And for those of you who don't know, the primary uses or where you see PoE or power over Ethernet in industry, the two most common uses that I know of are Wi-Fi access points in a large installation. So that way you're only running an Ethernet cable to each one and you don't have to worry about powering them. And IP phones or voice over IP, VoIP phones. Most modern business phone installations, desk phones, are basically internet devices communicating voice over internet connections or local Ethernet connections. And most modern PoE phones, that's how they're setting them up. You just plug it into a jack, and the jack powers the phone and provides it with the network. So I know in the building that I work in, which is a pretty modern building, there's one jack in each cluster of 4 that is also powered, and the PoE devices that you plug in there don't need to be plugged into any kind of other electrical source, which is really nice. So there's certainly plenty of ways that that would be really handy for some of the Pi projects if you already had the Ethernet line running to where the Pi was, but no way to power it. So cameras come to mind, which Jim will talk about, I'm sure. We have any other questions or comments? All right, that's fine. And this is W2NDG on the Sunday Night Science and Technology Net. When I did this for the HRU show a couple of times, I brought out the hardware and showed a couple of demonstrations. Early on, I had the Pi FM demonstration running. I don't have a working version of it anymore, but it just played music. The warning about what kind of antenna you hook it up to is first-hand knowledge. I hooked it up to my outside VHF UHF antenna. Obviously not tuned for FM radio, but I just wanted to see, you know, if this little amount of power would go anywhere. And when I got almost a mile away from the house and I was still hearing it on the car, I decided to turn around and unplug it before something bad happened. So yeah, if you do try the Pi FM experiment, keep the antenna short. I used to run the Whisper demo, and I would transmit right out of the Pi into usually a radio that I brought with me so you could see that it was running. This past HRU, I did a live FT8 demo using the Raspberry Pi and was able to log a couple of FT8 calls from the Pi. So neat stuff. There's certainly so much you can do with it. And I pretty much buy every version that comes out because I like to know what's changed. So I'm planning on doing some work with the cameras. I have to sit down and talk with Jim about it because even though I know how to do the computing side of it, I need to know a little more about the mechanical part that he has going. So I don't know if you want to talk about what you use the Pis for around the house, Jim, but you could do that. This is W2NDG, handing it over to K2BHM.
Thanks, Neil. K2BHM here. Oh, there's all kinds of things going on. I've got one set up with 4 digital thermometer chips. The Pi doesn't have an analog input, but they do make a digital chip that runs, I don't know, like $5 a piece. It looks like a 2N2222 transistor. And it interfaces through software right into it and measures temperature. And I've got one set up that is measuring the internal temperature of the living room, the external temperature outside, the temperature down in the boiler, and the temperature in the boiler room. And you can access it on the web from anywhere in the world. Webcams, they make a camera for it. It's 8 megapixel. I think it runs like, I don't know if it's $25. And it does 1080 video, or it does megapixel stills, plugs right into the board. And there's software right on the 835 website to interface it and set it up and look at pictures on the web. Let me drop a second. I got a VPN set up so that if you're out at the coffee shop and you want to use your phone and you don't want to take a chance on somebody hacking into you, you can run an encrypted tunnel back to your house, and it's as if you were sitting at your house instead of at the coffee shop. Multimedia server, take your pictures from your digital camera and back it up on the multimedia server, and you can access it from the Roku and put pictures up on your TV, do a slideshow. The Pi-hole, it acts as a DNS server that doesn't know what some of those sites are that are mining data from you or trying to put up ads all over the place so you don't get them. And it snaps up your performance on your other computers in the house. Yeah, there's lots of different things going on. Basically, just go out and Google and you'll find thousands of things out there to do with the Pi. You drop a second. So to get back to the previous topic, PoE, power over internet, or Ethernet. That's handy, but in my case here at the house, I'm never really out of Wi-Fi range, so it's easier for me just to plug in a wall wart, power the thing up, and access the Wi-Fi, and I don't have to run Cat5 cable anywhere. So when you start getting into commercial environments where you're going through concrete walls and steel floors and all other kinds of things like that, and you've got the wire all over the place anyway to Cat5, that's a slick solution for powering it up and data connection all on the same cable, and that's a very good solution. But in our case, we probably won't be needing that. I don't know, anything else you want to touch on, Neil? K2PHM.
W2NDG on the Sunday night technology, science and technology net. I have a couple of pending projects that I wanted to throw at mine. I want to set up a couple of moisture and high water alarms. I have a sump pump here at the house, and it would be good to know if it ever, gets near breaching. And a couple of spots where it would be good just to have like a moisture alarm. There's a little pit in the closet where my water storage tank comes in from my well, and there's a number of filter housings and UV, and I think it's a good weak point as far as possibly ever having a leak. So I may put a water sensor there. Jim talked about temperature monitors. My main house is already monitored by some smart devices, but it might be a good idea to have a temp monitor in a couple other places, possibly my freezer. I do have one of those big chest freezers. It would be nice to know that it's always operating at peak efficiency, and if something goes wrong, I don't find out 4 days later when I open it up that something happened. So let me drop. There's certainly plenty of radio projects, but I have a lot of those covered with the things that I wanted to do already. But one thing I've mentioned numerous times, and I've actually started to look into the displays for doing this, would be a device for monitoring the surface temperature of my wood stove and possibly the flue temperature as well. I think that would be really neat. And I'm thinking about making the device in two versions. One very basic one that just reads out the temperatures. Could be probably using a Pi Zero, very small. And a more deluxe one with a color touchscreen that would also have the ability to stream internet radio stations and play music. Hook it up to a nice pair of speakers up on the mantelpiece and have a little mini entertainment system that reads the room temperature, temperature of your stove, and the temperature of your flue. So I've started to think about what those devices would look like and what kind of sensors I would need to use, and I may dive into that a little further. But it's definitely something to consider. A long time ago, I thought about doing something as simple as a slow cooker monitor. It would monitor the internal temperature of like a large pot roast or something and allow me to switch the thing into warm mode from a remote location. I don't know if I'll get to that point, but there's certainly an endless number of things that you could be wanting to do with these things. So great little tool. Does anybody else have any questions or comments, or do we have any late check-ins?
W2GGF question.
Sure, go ahead, Matt.
Thanks, Neil. Had to step away from monitoring for a few minutes. Had something I had to take care of, so I don't know if anyone has asked. But I was wondering about FL Rig and Raspberry Pi.
Good question. The whole FL suite is pretty much available for the Pi. So Rig is there. And in fact, anyone out there who's ever had to try to play with getting FLDigi up and running correctly, or some of the other apps, sometimes you're best to use FL Rig as like a go-between between FLDigi and your Rig. This is something we could definitely get into on more of a like troubleshooting talk net also, is that to get rig control up and running with the Pi sometimes involves a little bit of finesse. I found that the newest versions of the Pi OS seem to understand that most users are going to want to be able to control serial or USB over serial devices. But it used to be that you had to get to the command line and change some permission settings so that any user could actually communicate with a serial device. I don't think it's a problem anymore, but it's a very simple fix if it is. Also, even trying to get rig control up and running on a regular PC sometimes can be problematic. Getting those little nuances of the serial settings, baud rate, and all the other little settings just right sometimes can be infuriating. I've found you can try it in several different apps, and once you get it right in one, look at the settings and try to mirror them in the other apps. And sometimes that doesn't even work right. But I do have it working to a point where I can control my IC7300 and also my Jigu. I've got it working with that, which is neat because with the little portable one that I set up, and I've got this whole little portable digital mode station that I can put out there. I also was able to get control running with a microBitX, which is the transceiver you put together after ordering it from India. So it works, proof of concept, and we could have troubleshooting night on that if people want to try it.
Okay, great. Yes, it is rather complicated. I thought it was just me. But I got it working with my Jigu G1M to the extent that I could turn on and off a couple of options and features using IC7300, but really can't do what I want to do with it yet. So, yes, another night. But thank you, KB2GGF.
All right, and great topic too. Anybody else with any questions or comments, or shift gears? Something else that you had a question or a comment about? Okay, I'm going to stir the pot a little bit, and I'm going to ask Jim a question about something he has set up. Jim, do you have outdoor cameras?
They're inside but looking outside.
Okay, so that answers that answers that question and eliminates the next one. I was going to ask you how you were powering them.
Yeah, no, they're looking out garage windows and looking out back windows and stuff like that, so they're inside.
Okay, that makes it a lot easier, for sure. I was trying to think if I put some, just a couple of them, because I have a commercial system already. I wanted to add to it a little bit just to keep an eye on a couple of things. But like you, I'm aiming for some of the same stuff. I want one on the the fuel gauge for my oil tank. I want one on the pressure gauge for the burner. And probably a couple in strategic locations where there's a lot of pipe junctions and such, just so I can keep an eye on things. But one of the things I noticed when we got into the weather nets and the weather reporting was that if you look at your Weather Underground page, there's a place where you can feed a webcam into your Weather Underground station page. And I thought it'd be cool to have one just showing the general weather. But yeah, I could definitely get one in the garage. And my far garage has a couple of windows, so that's probably the way to do it. I was expecting you to give me some long explanation of a solar panel and a tree and a lithium polymer battery, and we can work towards that.
Yeah. No, actually, it was kind of simple. I started off with a commercial webcam. It was like $35 from Newegg or whatever, and was playing around with it. And it had to have ActiveX to use all the capabilities, which is Windows, which is obsolete, and there was no equivalent to it for Linux. So you had to use smartphone mode, which basically just lets you watch the video and pan and tilt, and that was it. And I got playing around one day and happened to go nosing through the logs in my router and found out that this guy was calling home periodically to the Amazon web servers. And I didn't like the idea of ET phoning home and me not knowing why or what was being transponded. So that got me into the Raspberry Pi, and the only thing he does is call up looking for a time check every so often. So that started that project, and the Raspberry Pi camera setup. Let me drop a second. Is a good example of interesting Pi project. It is a whole bunch of different programs all knit together to come up with the outcome. It's something called a LAMP server, Linux, Apache web server, database, and PHP scripting language. And then from there, it uses the incorporated video driver for the camera from Raspbian, and sets it up on a HTML page, scripts it with PHP, incorporates radio control servos with click buttons to move the camera back and forth, pan and tilt. It responds to a touch screen as well on your iPad or iPhone or tablet, whatever. And it's basically just a whole bunch of different programs all knit together, and it works. So the possibilities are out there, and it's basically limited to your creativity as to what you can do, taking things that other people did and putting them together. K2BHM. K2KRP.
Go ahead, Kenny.
As you're talking about if you were to do remote cameras outdoors, would the Pi sit with the camera outdoors, or would you be able to remotely operate the cameras from in your house outside? And what would that contraption look like? So in other words, the camera would be speaking to the Pi through what, Wi-Fi?
Most likely. That would be the most reliable way to do it without running wires through the trees. I was looking into this because before I knew that that's how Jim was doing it, I was trying to figure out how I would actually get a couple of outdoor cameras out there. And it's interesting because I did come across some ideas.
I'm curious, what kind of cameras would you place outdoors? First of all, obviously weatherproofing. As you discussed, power. I would hope we could, could use lithium batteries. I have blink cameras all over the house outdoors. The batteries last forever. I'm able to monitor everything on the iPhone. I can restrict anybody who looks at the video. I have VPN, but using Raspberry Pi, I would much rather do that because then you really have more control without a third party. I'm just wondering what kind of camera would you use to connect to the Pi?
I'll start the answer and I'll throw it over to Jim for comments because I did some research on this. There is an official Raspberry Pi camera. Actually, there's more than one. There's a super high res model now, and I think they make an infrared version also. If not the official Pi, there are a couple of other ones. And all of the Pis, even the Zero, which for power consumption, you're probably going to be looking at something like a Zero, have a little ribbon edge connector that the camera plugs into. So that's how the camera goes onto it. As far as what to put it in, in my research, I've found two solutions. One is I watched a YouTube video where a guy did a project where he mounted the camera in a plastic, like utility junction box, and then made some pass-throughs for a couple of the wires and for the hole for the camera with grommets and sealer. He used an outdoor box that comes with a gasket. So the thing kind of is self-sealing once you get it all together. So there was a project like that I saw. The other possibility is kind of a silly thing that they sell is they sell dummy cameras for people who might have 2 or 3 cameras and want to make it look like they have 30, or even someone who has no cameras and tries to put some outdoor cameras up, or even indoor, to make people think that they're being watched. I don't know why you would want to do that, but there are dummy cameras that are relatively inexpensive, and you could actually put a Pi Zero and a camera inside of one of these. And some of them are robust enough to not leak. And yeah, a little silicone bead here and there, and you can probably seal them up pretty good anyway. But that's the first answer. As far as powering them, probably those lithium AA's like they use for the blinks. I'm not sure how long 3 of them, which is probably what you would need to get near the 5 volts. I don't know how long 3 of them would power one of these. Probably not as long as the blinks. The blinks are optimized for that. But it's one way to look at it. The other possibility would be, a small solar panel and lithium battery to charge up and see how long you can get off of one of those with some sort of switchable backup. This is a project. And, one of the issues here is, let me drop. As you get into something like this, the cost is going to start going up to make it not as advantageous either. It's still your project. You have full control over it. You can design it the way you want it. But the cost advantage is definitely going out the window once you start getting into this level. W2NDG. Back to Kenny for further comment, and then Jim.
Now, the cost factor would probably exceed what a blink is, but the fact is, to build something like that, to me, it wouldn't be the cost. It's the ability, the science, and as you and Jim keep pointing out, the fun of building something like that and having it work off of the Pi system. And I'm very intrigued by that. I mean, I have a number of Pis. Most of them are hotspots. But I got my son a 400, my grandson, and he's just turning 3, and he's already using it. He's already playing with it in its basic form, but he's learning. And it's an incredible learning tool. And listening to you guys tonight, and actually looking at articles while you guys are doing your lessons, there really are a lot of fun projects out there. So building an outdoor camera, although it could run into a little bit of money because of what you have to buy, it's not a matter of trying to save money for a project like that. It's actually doing the project and having fun with it. K2KRP.
Take it next, K2PHM.
Yeah, I want to hear your opinion on all this.
Okay, K2PHM. Well, first off, the Pi Zero is going to be the lightest. And right now, the software that I'm using will only access the Raspberry Pi camera that's plugged the interface on the board. It's, I don't know, like a 12 or 14 pin ribbon cable, special connector. And as set up, I think it draws somewhere, maybe like 7,500 milliamps at 5 volts. So I don't know how that would be towards battery power with solar, because I don't know how much solar you're going to get during the day. You have to get enough that you could run it for all night long. But anyhow, and they do make a little case for it that takes the Pi Zero and the camera and puts it together in one nice neat little package. It's about the size of a pack of gum, maybe a little bit bigger. So that's the one format that I use. The other format, Adafruit, has a plastic assembly. I think it goes like about 14 bucks or whatever. Let me drop a second. You take two of the standard miniature radio-controlled servos like you'd use for a model airplane or whatever, and they embed into this device so that you get a base that screws down with 4 screws onto something and attaches to the one servo, which gives you a pan, and then that attaches to another piece of plastic that encapsulates the other servo that gives you the tilt. And then the wires for both servos come down through and plug into the I/O pins on the Raspberry Pi. And so now through the Raspberry Pi, over the internet, you can get your video, you can take 8 megapixel pictures, and you can also keyboard or mouse or click or whatever to do the pan and the tilt. But then again, now you're going to be upping the power requirements for the 2 servos, but they only really take power when you're moving it. So let me drop again. So now basically the image sensor, the CCD image sensor for pretty much all cameras are very sensitive to infrared. And so they put a filter on so it doesn't degrade the picture that you get when you're using it for regular use, the regular color spectrum that the eye sees. So all the Pi cameras come with that filter built in. And there is a certain one that you can buy that says no IR, which means that that one has no IR filter in it, and it's much more sensitive to infrared. But be aware that it'll work better at low light conditions, but once you get into full sun, it's going to be pretty much blasted away. So you would probably want separate cameras, one more for night vision and the other for day vision. Because once you take that filter off, well, actually, once they don't put the filter on, you don't have an option. And let me drop once again. So as far as the Raspberry Pi and the cameras and so forth and so on, I do have a couple of them out in the garage. And the garage is unheated. So in the middle of winter, it can be 0 or 5 or 10 below 0 that the cameras are actually operating in. And that doesn't seem to be a problem. They seem to be functioning very nicely. I've got the ones in the house, they're in a controlled temperature, and I've got the other ones outside in the garage that the temperature varies, and it doesn't seem to make any difference. Let's see, what else do I need to cover? I think that's it. Any other questions? Kenny, K2BHM.
First of all, thank you very much for that explanation, both of you, Neil and Jim. Simple last question. Are the cameras motion detectors, or basically, if you want to see something, you go to your iPhone or whatever, and you pull it up on the screen?
I'll take that one. The simple answer is yes. They do put a web page up, and you can take any computer or smartphone or whatever and navigate to that web page and look at live video and click on the arrows and make it pan and tilt. Or if it's touch screen, you can touch the screen and pull it, and the camera will follow your finger, and it will do the live stream. You can set up a motion package, which will start recording if it detects motion in the image. But in my case, you get a squirrel running across the lawn or a windy day and the trees are blowing, it's going to be taken anyway. So I do a time-lapse mode. It takes one 1080p picture per second, 24/7, 365. And it breaks it up into 10-minute segments and creates an MP4 file and saves it on the Raspberry Pi's hard drive. So taking a picture a second, 1080p, a 1 terabyte drive saves about 8 or 9 months of video. So it's very economical there. So you can view it live, you can time-lapse it, you can record it, you can copy it over to a server, download it from it, all kinds of options there. K2VHM.
You've answered my questions. Thank you very, very much. And you said Adafruit, is that the best place? Because I have been looking at some of their cameras. I just want to make sure I'm looking at the right thing, but it sounds like I am.
Yeah, Adafruit, they've got a package there that has the Raspberry Pi camera, a Pi Zero W, the red and white plastic case for it, and the wall wart powered up. And I think if I remember right, it was, I don't know, like $45 or something like that, $50 for the whole kit.
Okay, thank you very much, folks. Thank you. Learned a lot. K2KRP.
All right. Kenny, thanks for the question. Jim, thanks for the great answers. Yeah, there is so much that you can do once you shrink the computing part of this down and make it so versatile and so inexpensive and so accessible. That's the other thing. It's just so much information on these things. It's great. I was thinking of another one, Jim. Soil monitor, moisture monitor in the garden. And this, I'm sure there's other sensors available that monitor even other things than just moisture in your garden. You could do whole sunlight studies with these. They make equipment for that. I mentioned the weather stations. You can really get a deep dive there, and by all the various sensors that are available for these things, you could really build a pretty advanced station to your own design, not have to rely on somebody else's version of a weather station. So really cool stuff. This is W2NDG on the OMARC Sunday Night Science and Technology Net. One more call out for questions, comments, or really late check-ins. All right, I think we're going to close things up. We're going to spend between now and next Sunday throwing some ideas back and forth and some of the listener-generated topics that have come up. And then we might get a little elemental again the week after that. But I think next week is going to be in the hands of the members and the listeners. So we'll look over the list we've already gotten, and we may be polling some of you through some of the other nets and get some ideas of what you'd like to talk about next week. Thank you for participating in our little presentation experiment tonight. It was just something that I wanted to see how it would work, what it would look like, and how it would turn out. I did post the link to the HRU presentation, which is basically the same presentation. And it's both on the 835 on the 805.net and on OMARC's Facebook page. If you search for OMARC, you won't find it, but if you search for Overlook Mountain Amateur Radio Club on Facebook, you will find it, and the post is there. Let me drop. You've been listening to the Science and Technology Net on the Sunday Night Science and Technology Net on OMARC, a repeater of the Overlook Mountain Amateur Radio Club. This club runs 2 nets every day, the 835 on the 805 net in the morning, run by Paul, ACTUQ, also Rob, W2RWS, and Jed, who my terrible brain can't remember Jed's call sign right off the top of my head. That net is at 8:35 every morning. It's an informal roundtable net where people come on and talk about what's going on in their lives, how they're feeling. Came about to kind of support our pandemic habits and to replace some of that social interaction that we were all needing. There's a net every night at 6:30, which is the 6:30 check-in net. Similar purpose, similar topics, a slightly more formal directed net run by various members of the OMARC Club and on a rotating basis, and that is also 7 days a week. Thursday nights at 8 p.m., Dave, K2JLV, our president, runs a directed formal technical net that explores usually troubleshooting problems, questions, and if the listeners don't pick a particular topic based on what somebody's needs are, Dave throws a great subject out. Like tonight, when we were talking about Raspberry Pi in general, we might get into a more specific topic like we did at the end here with getting the cameras to work or getting SDR to work on the Pi. There's another topic. We were talking about SDR on the repeater the other day, adding a large waterfall display to an existing HF rig was another topic that we thought might come up on one of the Thursday nights. But Dave is in control of that, and he always picks something good for us to all talk about and help people work their issues and problems out. Let me drop. As has been mentioned a couple of times, you do not have to be a member of the club to participate in any of these activities or nets. However, we do encourage it. We're a great local club, great bunch of people, and we'd like you to join in as our in-person activities start ramping up again, but the virtual activities are also just as fantastic. You can find our club online at omarclub.org. That's www.omarcclub.org. And as I mentioned, you can find us on Facebook as well under Overlook Mountain Amateur Radio Club. This has been Neil, W2NDG, on the OMARC Sunday Night Science and Technology Net. Ending the stream and ending the formal net now. I'll hang out for a few more minutes if anybody has any questions. But good night all, and good night, Jim.
Thanks, Neil. Good night tonight. Lots of good information and good coverage. Thanks, KGBHM.